solve it for y. It will be x into x square or x cube plus x into y square is equal to ax square minus a y square. If I take y square, this a y square to this side, it will be a plus x into y square. It will be this value. If I take x square common, it will be a minus x. This x into x square, if I take to this side, it will be ax square minus x cube. If I take x square common, it will be a minus x. This is a plus x because x y square and plus a y square taken to this side. Therefore, y square is equal to x square into a minus x upon a plus x. So here, the value of a plus x 0, a x equal to minus a minus x equal to 0, x equal to a is calculated. So this is the figure of this kind we have obtained here. So y equal to here, this is x under root a minus x upon a plus x. Right on this one. These are the limits for y here. Y 0 to this. And the limits for y 0 to this and x 0 to a. For a we have taken for the upper loop. And then twice of this whole will give us the whole, that is the area we have to cut. Okay, so that is the question here. Now let me solve it. So this is y equal to here, y equal to x under root a minus x upon a plus x. This we have calculated here. So let me find the final area. Therefore, area, total area of the loop, this whole loop, is equal to twice limits for x equal to 0 to a, this is minus a here, x will 0 to a, and y limits are 0 to this x under root a minus x upon a plus x into dx dy. Okay, this is to be integrated, and then twice of this whole will give us the answer. Now let me solve it. So finally, I'm solving this as twice 0 to a for x. Now with respect to y, we have to integrate this. It will be only integration of dy y. Limits are 0 to x and root down do directly. A minus x upon a plus x into dx and log. But with respect to y, we have integrated this because the first limits from the right hand side are in terms of x, it means they are the y limits. With respect to y, we have to first integrate. That means y here, limits are 0 to this. That means substitute the limits a will be, therefore area, total area A will be, in order to develop this figure, total area is equal to twice 0 to now y, this is this, because at 0 to 0, y limits are x and then a minus x upon a plus x into ds. Now this is to be integrated further. This integration will give us the final answer of this question. What is the answer here? Let me take it twice. Now it is to be rationalized, multiplying by under root a minus x in the numerator and denominator. If I multiply numerator and denominator by under root a minus x, with this under root a minus x, under root a minus x in the numerator, it is 0 to a x into a minus x only divided by under root a square minus x square, right on this into ds. Now if I substitute x equal to now something as a sin theta, a sin theta. Now putting x equal to a sin theta, because here a square minus x square is there, that can give us something. Therefore dx will be a cos theta d theta, because differentiating it with respect to theta, with respect to theta, we get this dx upon d theta equal to a cos theta. That means Ax equal to a cos theta d theta. What are the limits? Let's find out the limits here. At a, at x equal to a, sin theta equal to 1 into sin pi by 2. That means theta is equal to pi by 2. And at x equal to 0, theta equal to 0. Why? Because sin theta equal to 0, that means sin 0, theta equal to 0. The limits are y is 0 to pi by 2. At a it is pi by 2. X is a sin theta. In bracket it is a minus a sin theta. Okay. A minus a sin theta. Now this is a cos theta into d theta. Value of dx, a cos theta d theta, divided by here under root a square minus a square sin square theta. Okay, that will give us into d theta is there. Okay, so finally a is equal to, let me write here. Therefore, a we are finding out y is 0 to pi by 2. There is a sin theta a into a is also there, so this will be 1a from here. A cube will come out. This is a cube. From the denominator we will get a. So this a is square. If we take from square root, it will come out as a cube in the numerator, a cube in the numerator. We get sin theta into this cos theta will be, okay, let me write. This is sin theta first one minus sin square theta. So this sin theta and sin theta, sin square theta, divided by cos theta into cos theta d theta. So this cos theta cancels out. Okay, the a we have taken common. Alright, this cos theta and this cos theta cancel out. Only sin theta and this sin square theta. Now let me do them separately. You can integrate them side. This is twice a square over 1a. Cancel out. So this is 0 to pi by 2. That clearly is sin theta into d theta. Let me separate them. Minus it is 0 to pi by 2. It is sin square theta. So these two terms, sin theta, sin square theta, have been separated. This is twice a square. Twice we are multiplying because this is 2 times of this figure. Upper limit, upper portion. Twice of upper portion means the whole area is calculated. Twice a square. Now this sin theta is cos minus cos theta integration. Limit 0 to pi by 2. Okay. And let me write here. This bracket of this whole bracket minus this value sin square theta. Now integration of sin square theta by Wallace formula is, this is even number. So if it is 2, then it is 1.2 into pi by 2. Alright, so integration of this. This is now at cos pi by 2 0, but cos 0 is 1, minus 1 plus, that will be plus 1 twice a square into 1 minus only this. Was at 0, it will be 0, sorry, it is this whole value. This pi is equal to 4 only. Twice a square into 1 minus pi equal to 4. Or we can take 4 only. It will be 4 minus pi. Let me that also. In that way also it can be written. A is equal to twice a square of 4 into 4 minus pi into the 4. That means a square from 2, 4 minus pi, this is answer. So question number 10th we have done. Question number 10th. Okay, so twice of this figure has given us the whole area. Now the next question is what kind? Let me now think about 11th question. Now it says that the area between one arc of the cycloid this, and its base is 3 pi is we are looking here. Question number 11. Okay, so question number 11, it says the area of the loop, one arc of the loop, so that the area between one arc of the cycloid, the cycloid here A into theta plus sin theta and y is equal to okay, y equal to A into 1 minus cos theta. Okay, now limits we have to find out, and its base, so area between its base and this is area equal to 3 pi a square to this we have to prove here. Go to the base here. Now define this figure. So this figure will be, I have to just one of the arc of this figure. Okay, so this is the x-axis, y-axis. If I take this figure, let me draw this proper figure. This is the parabola and this is the arc here. This is the arc of this. Between these two arcs here, theta k is equal to theta equal to pi, and here theta equal to minus pi. In this figure, this one, area of this whole figure we have to find out. Again, we have to find out area of this to this figure. For that, limits of y will be from this arc to this arc, this value. Okay, now let me talk about this. Here theta is pi. If I substitute, y will be a into, this is minus 1 because that's cos pi and theta is pi here. Okay, so at theta pi, at this straight line, theta is pi here, theta minus pi. So this theta pi with cos pi is minus 1 plus 2 twice a, y equal to twice a. On this line y equal to twice a, but at this equation y equal to this value. So limits for y will be, lower limit will be this on the arc, this is this a 1 minus cos theta, and 2 y equal to twice a, y twice a, because that pi, theta equal to pi, upper limit in this line, okay, will be cos pi is minus 1 minus 1, 1 minus 1 minus, sorry, minus plus 1 plus 1, that is 2 twice a, y will be twice a. So limits for y are this. What about x here? Limits for x from this point, okay, up to this point here. For that also we have to find out here sin pi is 0. This is a theta, a pi is pi here, a pi 0 to a pi. X will be limits for x will be 0 to a into pi. Why? Because if I substitute pi here in place of this upon the upper limit, so sin pi 0, pi is this a pi, 0 to a pi. But why show this figure? Because this only we are calculating by finding out the limits. So this portion will also be included. So twice of this whole figure will give us the whole area. Therefore, area solution let me find out. So area of this whole figure, area of the loop, arc of the loop. So the area between one arc of the cycloid, this, and its base, cycloid, one arc of the cycloid. This is arc of the cycloid here. Okay, so one arc of the cycloid cycloid will be twice of this whole. Right? Area A is equal to twice of limits of x is 0 to a pi. Try to understand. And the y limits are 0 to this a into 1 minus cos theta to 2a, and this is dx dy. Because this is in terms of theta, we have to put here r d theta. Okay, but before converting that into theta, let me write here dx dy. Because here dx is this value that we have to convert, and the dy is from this. Okay, so dy is to be converted from here. What is dy? Okay, that we have to find out from there. Dx and dy. Dx and dy. Now dx is 1 theta with respect to theta, dx upon d theta. Integrating this theta here. This is 1 plus cos theta. A into 1 plus cos theta. And this is differential this will be this plus a sin theta only. Dy is a sin theta. Okay, that is the value of this value is twice 0 to a pi. This is a into 1 plus cos theta into dy. If I find out from there, it will be that value a into cos a into sin theta. But because this is with respect to theta here, d theta. Now r d theta dr, we have to find out. Okay, if I convert this into polar coordinates, then what it will be? Okay, so limits of this. Okay, here d theta is this a into 1 plus cos theta. Okay, now we will solve it here. So dx dy is this, because we have to convert this into terms of theta. And theta we are getting dx dy. Okay, or we can write here dx dy, no problem. Limits are these. After putting the limits, then we have to convert them into limits. That is to be solved here. Now let me solve it. This figure let me remove now. So, the limits of this function. Therefore, area A is equal to twice 0 to a pi into a into 1 plus cos theta, a into sin theta, y into d theta. Because limits we are not selecting the proper limits. 0 to a, 0 to twice a was also there, 0 to twice y limits. So dx dy we could write here. Let me write here dx dy, no problem. Here it is dx dy, still it is dx dy. We have to limits are here 0 to 8, 1 plus 1 minus cos theta. Limits of this a into 1 minus cos theta to this value. Okay, and dx if I find out from here, it is a into 1 plus cos theta. This is the value of dx from this figure. And the dy, if I integrate this with respect to y first, it will y into, let me write here, dx will substitute this value finally before integrating this with respect to y. But y is here, sorry, this y we have integrated with respect to y, it is 0 a into 1 minus cos theta into dx still we are writing. Now let me substitute the value of y just to this limit. It will be y is 0 to a, y is twice a minus a into 1 minus cos theta into dx. Okay, this is A twice A minus A, that means A minus A cos theta. A minus A cos theta. This is, let me solve it further. This is A pi twice A minus A. This is plus A cos theta. It will be A plus A cos theta. A cos theta into dx, but dx is this value A into 1 plus, because if I find out dx with respect to theta, d theta, then integrate it with respect to theta. So it will be A into 1 plus cos theta. It is dx means A into 1 plus cos theta d theta. Value of dx. Limits will be then 0 to A pi, because if I put here A pi, we cancel out A pi equal to pi. The limits are 0 to pi. A, if I have taken common from both, it will be A square. 3 into pi. This is 1 plus cos theta whole square into d theta. Okay. This value is there. Now we have to integrate this with respect to theta. This is A pi we have taken because pi limits are there. This twice A square. 1 plus cos theta is 2 cos square theta by 2. It is 2 cos square theta by 2 whole square 0 to pi into theta. Now let me solve it further. So A is equal to, therefore 2 pi, sorry, 2A square, this we are solving. Now still it is 0 to pi. This value is twice cos square theta, that means 4 cos square theta equals 4, sorry, cos 4 theta by 2. Now if I put theta by 2 equal to some limits, putting theta by 2 equal to t, so at pi limits, okay, this will be 1 upon 2 or d theta equal to twice d. The value is coming, okay, let me check it. So it is this value 2 dt, alright, d theta equal to, only limit on taking the at pi, it is pi by 2 t equal to 0 it is 0. Limits are there for limits at theta equal to pi, t equal to pi by 2, at theta equal to 0, t equal to 0. So limits are, this is I think 4 to the 8, and 2 is also have come out from this. It is 16 A square 0 to pi by 2. Limits, it is cos 4 t dt. This 2 of dt, this twice of dt are taken outside. 4 to the 8 and this 2 also 16. Now let me integrate this. Now this is by Wallis formula, reduction formula. So the reduction formula from Wallis formula will give us 16 A square 3 by 4 1.2 into pi by 2. Right one is why it is, because cos 4 theta is there. Cos 4 t dt 0 to pi by 2 limits by Wallis formula. Since reduction formula, since applying reduction formula, or Wallis formula, it's known as Wallis formula. Applying the Wallis formula, we get this value. This 4 to the 4, 4 to the 16, 16 cancel out to this 3 into pi into a square. This is the answer here. Area is 3 pi square. Good. Hence the same answer is obtained. Area, which is 3 pi square, 3 pi a square, has been obtained for this question. 4 to the 8 and to the 16. Okay. This is the question which we have done here. 11th question, and let me talk about 12th question. 12th question, let me talk about. Now, question number 12, what did it say? Okay, now question number 12. Now it says, find the area enclosed by the lemniscate this using double integration. This question before is given to us here for r square, small r square equal given r square equal to a square cos 2 theta. Okay, this is in polar coordinates using double integration. Okay, using double integration, multiple integration. We have to find the area of this, find the area enclosed by this lemniscate. Look at this form of lemniscate. Let me first define that. So, solution here. Now, this form of lemniscate is of what kind? Now, let me change the marker. So, the formula or this figure will be of this kind. Lemniscate this is the lemniscate. 4 figures are there. If I find out area of this only portion, the limits will be of theta. Let me take theta here 0 to pi by 4. This is pi by 4 here. Okay, this is pi by 4. 0 to pi by 4 if I take, then 1, 2, 3, 4. So 4 times 0 to pi by 4 either. Or I can do, if I find out the area of this hole, then limits will be of theta minus pi by 4 to pi by 4. Okay, and the r is 0 to a here. This r equal to 0 to, at this curve we have r is equal to a under root cos 2 theta. Try to understand. On this curve r is equal to, this is P point, this is P point here, P point here. If I find out the r, this is r here, r0 to 0, 0, x axis, y axis, and s axis. This whole area we have to find out of this loop. Now, one thing, if I find out the area of this whole curve, take the limit, then minus pi by 4 to plus pi by 4 for theta, r is okay, 0 to r equal to this, and twice of this area will be equal. Or we can take limits 0 to pi by 4 of this section only, and make 4 times of this. 4 times of this will give us the whole area. Let me take that kind of situation. So here, the limits for r equal to 0 to r equal to 0 to this a under root cos 2 theta, and limits for theta for the positive this positive portion of the loop, positive portion of the loop is r 0 to pi by 4. Try to understand. This is 0 to pi 4, 0 in the x-axis, theta value, and up to this point it is pi by 4. 0 to pi by 4 if I take, then it is 4 times of this whole figure. 4 times of this value will give us the area of the whole figure. 4 sections are there, 1, 2, 3, 4. Okay, then 4 times. If I take these limits, then 4 times of this whole. That is the point. Or if I take minus pi by 4 plus pi by 4 limits of theta, then twice of that, so this portion, these two portions are also included, then 2 times of that. That is the portion possible answer is to therefore area A is equal to limit theta 0 to pi by 4. Let me write first this, or this is 4 times total area. 4 times we are finding only this portion, the upper portion of x and y axis. Okay, that one positive loop of the portion, positive loop only. That means 4 times of that answer will give us the whole area. 4 times of this 0 to pi by 4 into our limit is 0 to a under cos 2 theta into r d theta dr. Okay, these are the polar coordinates. We have converted this into polar values given in polar coordinates. Now this is r here, this is theta. So with respect to r, first I have to integrate this. So let me integrate this first r times r with respect to r, then with respect to theta. Area A is equal to 4 times 0 to pi by 4. Okay, so integration will be r square from 2. This is r here, r square from 2. Limits are 0 to a under cos 2 theta into d theta naught. So the area finally, let me sort. The final area will be 4 times 0 pi by 4. This is r square, only upper limit will be substituted. A square cos 2 theta into d theta upon 2, who are taken outside, 2 times out. This 2 can be taken outside, this is the value. It is 2 times 2a square here outside, 0 to pi by 4. Now cos 2 theta, we have to integrate this. This is cos 2 theta, can be integrated easily. So this is nothing but twice a square sin 2 theta positive upon 2 integration of cos 2 theta 0 to pi by 4. Firstly pi by 2 only. This is twice a square upon 2. This 2 will come out, and 2 theta, if I put theta pi by 4, it will be sin 2 into pi by 4, that means sin pi by 2. Sin pi by 2 is 1. Okay, at 0, which is 0, minus 0. So only 2 a square is the answer. Final answer is equal to a square. This much is the answer. Only a square is the area of this whole